All right, feel free to start whenever you're ready.
All right. Yeah, thanks for having me. This is going to be pretty informal. I don't really have slides prepared, which is why I'll show you a demo. So I'm Andreas. I'm one of the founders of Odd. Odd is a nonprofit machine learning research lab. And mostly today, I'll show you a prototype that we started working on that uses GPT-3 for supporting reasoning. We only started working on this prototype about a month ago, so this is going to be pretty rough, but I think it's one of those things that it's kind of better to get feedback early on. So I thought it would be pretty interesting to see what you think. So I thought I'll say a few more words of context about myself and about Odd in case you don't have the context already, and then I'll just jump into the demo. So for me personally, I spent most of the last 10 years in academia, did a PhD in cognitive science at MIT, and then a postdoc in probabilistic machine learning at Stanford. And I've kind of always been interested in how we can kind of delegate reasoning to machines. Thought about, should I stay in academia? But then it kind of seemed like making progress on this problem required like more engineering and longer timescales than were easily feasible as a kind of tenure track academic. So decided to start Odd. And then for Odd, Odd's mission is to automate and scale up fairly open-ended reasoning. So we think there's some chance that progress in AI can like make good reasoning much more broadly available. We think people are not great at reasoning for the most part. And so this is a thing that could really make the world a lot better. And so we're trying to work on tools, one of which I'll show you today, that try to apply advances in AI to this task of like helping people think better. And our approach in general is just make reasoning more explicit, like make the individual steps of reasoning more explicit so that they are the sorts of things that can be like shared between people and can be automated. Over the last year or so, we've started like kind of zooming in on judgmental forecasting as an application domain. So judgmental forecasting is the sort of forecasting that super forecasters do, or like the sort of forecasting that requires reasoning out causes and effects, as opposed to like more regression style time series type forecasting. And that is like sort of the context into which the prototype that I'll show you fits. So this prototype we built for initially, or we kind of collaborated on this prototype with an organization called CSET, the Center for Security and Emerging Technology at Georgetown, and their whole thing is like work on forecasting, reasoning about the future, and so this is a tool that is supposed to make their life easier, but you'll see it's a pretty generic tool. I'll start screen sharing, and I'll show you what it looks like. Okay, so this is the tool. Like I said, it's initially it's going to be a tool for forecasters that helps them kind of take questions they're thinking about, like what's the future of US-China relations, for example, and helps them think about those questions. And the way this tool works is it has two parts. There is an actions part and a runs part, and the runs part is where you'd spend most of your time. So the runs part is where if you're a forecaster and you're working a specific project, you're kind of brainstorming and doing literature review and so on. And the actions part is where you make the tool better. So I'll show you what I mean by actions, but basically the tool has like different kind of cognitive steps available, and you can define new ones under actions. I hope we get to like defining a new action. I think it's one of the most fun parts of this tool. So let's go to the runs part. Make a new run. Well, there's a lot of stuff here. Let's get rid of some of this stuff. I've like created a lot of actions as part of just playing with this tool. Okay, and so the way this works is when you start out, you have this kind of outliner, like if you know workflow or row, it's the same sort of thing. And you start out as a forecaster by typing a vague question that you're thinking about. For example, what is the future of AI investment in China? Like those are the sorts of questions the people at the think tank I mentioned generally work on. So they're pretty vague. It's a general research theme on to which you might want to build more specific projects. And like by the time you have a specific project, like this is operationalized more. And some of what the tool I'm showing you is supposed to help with is that sort of operationalization. So I'll go through a few different steps that kind of mimic the sorts of steps that the policy analysts go through when they think about questions like this. And when we talk to them, most of them said like the most important thing, or one of the most important things for them, is that the questions they work on are like interesting to their stakeholders, like their stakeholders being like people in government, perhaps to some extent people at other think tanks are also thinking about related questions. And so we made this action, which is like CSAT stakeholder questions, which searches through relevant questions that people have asked CSAT before, and then says, here are the most relevant ones. So if I click on this, it'll make proposals for different actions. And all actions are going to work kind of like this one. So you have this menu, you apply it to a particular node in this tree that we're building in the background, and then you get kind of answers that you can add to the tree if you click plus. So here, the questions I got were like, will China's spending on AI increase in future years? So it's pretty relevant. So I check it and it gets added in the background. It got added to this tree now. Is there a more granular breakdown of how China is spending its investments in AI R&D? How much is China spending on AI research? How do their priorities differ from those in the US? And so on. Basically they have a list of 200 or so questions, and this is just a semantically sorted list of those. This sort of search is using GPT-3 to do the sorting. So this is one example of a question. This is an example of a search action. I'll also show other types of actions in a bit. But
It's just a quick question. So is what you said that based on the meaning of the root node question, it's like curating a list of relevant questions, or how is it creating that list?
Yeah, so there's an existing data set of like 200 or so questions that they have been asked, and then basically this one that list is sorted based on how semantically related each question in that list is to the root question. So that's an example of a search action, and I'll also show more free-form generation actions in a bit. Another example of a search action is like CSAT publications. So this one searches over all publications that this particular think tank has had in the past, and you can like do the same thing as with the stakeholder questions. You can just look over them, like here, tracking AI investment, 2019 report on conditions and trends in AI. You can kind of go over them, and the ones you like, you can add to the tree in the background. Chinese AI R&D spending findings, and so on. Like it's a very long list. So you kind of, I guess, you can kind of think of this as like a checklist for thinking, where you're trying to operationalize a bit more. What is the process that these analysts go through when they try to answer one of these questions? So part of the process is try to understand, what do stakeholders want? Try to understand what is the related work in this space. Another way to do the related work thing is by clicking on this Foretell questions action. So Foretell is a prediction platform like Metaculus or Good Judgment Open or other prediction markets that this think tank set up. And so this action just like does a semantic search over all questions there. Like here, one that it found is like, what percentage of US AI publications will have a Chinese co-author in 2021? Seems relevant. A little bit relevant. I mean, whether these are, how much new funding will facial recognition companies raise? Also a little bit relevant. Okay, so those were all search actions. And then at the point where these people generally feel like they understand both what stakeholders want and what relevant existing work there is out there, then the next step you might want to take is you might want to operationalize the question a bit more. So this is an example of a generation action where you click operationalize, and then it kind of generates new ideas for more concrete questions you could ask. Like these are all the kind of questions that, for the most part, have a number as an answer. So these are like more measurable questions that could inform the overall question here. So again, this is like using GPT-3 to generate these examples. So here's like, how many AI research will there be in China? How large will the AI venture capital market be? What percentage of the total research and development investment in China will go to AI? It's relevant. What will China's GDP growth rate be? I guess this is 2019, less relevant. And then sometimes you get errors if GPT-3 API is unavailable. And then you have, okay, I'll ignore this one for now. And then, so if you operationalize it, then each node in this tree is like the same type of thing as the root node. So if you want to, you can apply any of the actions that I showed you to any of the other nodes in the tree. So I could like click on a node here, and then I could again click operationalize, and then it'll suggest questions to ask that could inform that question. Like how many graduates will China have that self-identify as AI researchers is like maybe a slightly more specific version of the overall question here. And then in general, there's when you select answers, you can also click refresh. And then what it does is it will generate answers that are more like the answers that you've chosen. So there's like interactive feedback that is basically happening while this is while you're selecting answers, where it will redo your suggestions based on the ones that you already added to the tree. How many AI startup companies in China? How much funding will companies? What proportion of AI engineers will be foreign born? How many graduate AI engineers does Canada have from Chinese universities? That one seems relevant. So you can basically generate arbitrarily many suggestions. Personally, I found GPT-3 and language models more generally like most useful for brainstorming, like because the individual proposals don't need to be that great, as long as they kind of prompt ideas for things that you wouldn't have thought about yourself. And you can just like basically keep going forever, and it like never gets tired of generating things. Okay, so that was a simple example of like applying an action recursively in the tree. We can also, the ultimate vision for this tool is to kind of compose together like actions of different types. So first, maybe you operationalize an action question to go to how large will the AI venture capital market be, and then you apply an action like now suggest a data source for this, like Crunchbase. And so you can see how like by composing together these different kinds of cognitive steps, like you kind of make it easier for people to go through this process, because people only have to say, oh, you know, I wanna take this step, and then they automatically get the response, and then they can like apply some other action to it. So that's how you use the tool. And then the other cool part about it is that like all the actions are kind of not really built into it, but are just things that users defined in this tool. So I can go to the actions view now and show that to you. So maybe the easiest way to demonstrate it is to just make a new action. So we can make an action factors, and what we want this action to do is it should take a question, and then it should give us like relevant factors. So like for each of the questions below, I'll suggest some factors that are important to consider when thinking about the question. And then the way the tool works is like you generally start by adding a test set. So where the test set, it can just be a question. Like suppose my question is something like how many industrial robots will companies have? And then I'm not gonna, initially for the test set, I don't need to provide any outputs. And like here are the initial suggestions by GPT-3, which are really not very good. I guess they could be even worse if I remove the instruction. Let me remove the instructions for a moment and then look at them. And then like, these are like not really factors. I guess TPM is not considered in this research. Developed economies are assumed to have higher demand, includes robot produced in China. Like it's like vaguely kind of topically related to the question, but it's not a relevant factor. And then as you add instructions and training examples, these will get better. With instructions, it's still not good. So I'll add a training example like what percentage of robots in the US will be produced in China? And then for a question like this, I want it to give me factors like, are there tariffs on US imports from China? Or like, what's the growth in the number of US robot factories? And so with each example that I add, I guess this is kind of stochastic, so we'll have to see what happens. But with each example that I add, like in general, the factors that are suggested for the test questions get better. And I think they kind of have like price of robot, income, competition. And so usually I want to add at least like 3 to 5 examples for the kind of predictions to be good. So, oops, let me add another like pretty different example, like when will space mining be profitable? And then I want to add factors like that depends on NASA funding. It depends on like how like what are asteroids composed of, depends on how much people invest in private space companies, depends on like how many mining missions there are. See what happens. Okay, and I think it's getting like a little better. So there's like proportion for robots to humans working in a factory, cost of a robot, number of used robots will be used. That kind of makes sense. I'll add one more example and then I'll just stop here. Like, is the US retaining foreign talent with AI skills? Depends on immigration laws, depends on US job market for AI jobs, depends on international job market for AI jobs. So let's update this again. Let's see what happens. Okay, how many company growth, employee use, job market? Yeah, I think it kind of got worse here. So should I add another example? I think sometimes it's like over-indexing on the examples, and it's not, you know, getting that the thing you're trying to communicate is I want factors for the question. So in real life, I would probably add like more examples here, but in this demo, I'm not. I'll just leave it at the like 2 examples. But the basic idea is, so you define your action factors. So this is my action, and then we can go back to the run that we made earlier, and then we can say, okay, I want like this factors action that I just defined to be available in this run. And then I can apply to any node. So I can apply to the original node, like what's the future of AI investment in China? Now it shows up here as a factors button. I click on it. And then if things go right, it will suggest relevant factors. So quality of Chinese AI graduates, number of investment in AI companies, amount of investment, number of patents filed in China for AI tech, growth of AI startups. I think these are actually like fairly reasonable, especially given that we only provided 2 examples for the training set when we defined the action government funding for AI research. Okay, so that's the basic idea behind this tool. You define these sorts of cognitive actions, and then you can apply them and compose them together with other actions, and then kind of automate some of the reasoning steps that you go through, in this case for forecasting, but the app is like basically fully general, and I've used it for other things too, like, I don't know, suggesting music to listen to that fits a particular mood and like strange things like that. Okay, that's basically all I wanted to show on the demo side. I'm happy to answer like questions or chat about tech feedback, whatever people find interesting.
Something that I found interesting here, I'm not super like familiar with machine learning and AI and that kind of stuff, but I am sort of in the UX design space, and part of that, something that's like difficult for me is like brainstorming and coming up with these questions, and operationalize is a word I hear a lot, and I noticed you said that one too. So do you think that this sort of tech could be used in sort of, I guess, brainstorming and coming up with design ideas? Is that an application?
Yeah, definitely. I think especially in cases where you can provide a few examples of the sort of thing you're looking for, I think it's pretty good at just completing like lists of examples and generating other things in the space. Like for things like thinking about company names, for example, I think it's pretty useful. You're like, well, here are the 3 possible company names. Give me 20 others. That's the sort of thing it's pretty good at.
Mm-hmm. And what sort of like, how is this like the business model here? Does it, is this something anyone can access, or is it something that you reach out to certain companies to help them, like you said, operationalize and brainstorm this kind of stuff, or how does it work on that end?
I guess right now we're probably going to start with like a few sort of power users who will use it a lot, and then will also give us a lot of feedback on how to make it better. I think eventually we want this to be pretty generally available, but it's still, I think there's like, I guess there's a lot of kind of that is still like rough about this app, and like that probably the UX is like not great. So I think it'll be good to have like a few users who are very invested early on, and then over time expand the circle.
Mm-hmm. Yeah, that makes sense. Thank you.
What's your vision? Where you in terms of the future? Where are you going with this?
Automate all reasoning about all questions. So basically, I think the ultimate vision is something like Google, but for questions that require like thinking. If you ask a question like, how likely is Trump to run for president again in 2024? I think you could think about like, well, what are the relevant factors? What are the things that push this probability up or down? And then like do like research what have other people said about this, how much can I trust them? Those are like all kind of like steps of thinking that right now people have to do, but that like some of them we can hope to automate, and over time as machine learning gets better at doing tasks that are more like reasoning, like I think we want to make it so that those tasks can kind of be done in a relatively transparent way. So I guess if you look at the, maybe I should briefly screen share again. Like a lot of the way we think about the things is like by having these relatively clean decompositions of overall tasks into smaller tasks, and then thinking about, well, how can we aggregate the results of smaller tasks into what the overall answer is. And so we're hoping to find ways to use AI to basically do this sort of relatively transparent thinking, but just do a lot more of it than humans could do.
I had a question. I was wondering, what are some of your the struggles that you're having with this program, and I guess what's holding it back? And then my other question is, how do you eliminate bias within your algorithm here to, because a lot of their answers about the future are our answers are biased. How do you eliminate that from your program itself?
Yeah, good questions. And in terms of struggles, I guess the main thing to make sure is to make sure it's actually useful. I think it's I guess this is maybe a difference between when I was in academia and now. I think it's very easy to make cool tech demos, but then if you're forced to kind of confront, like, if there are real people who work at a think tank, like they have a pretty high bar for like what in fact is useful, and that you're competing against like Google Scholar and like a lot of other tools in the world. So I think the bar for making something that is actually useful is just pretty high. And so the like being both at kind of at the forefront of machine learning stuff, but also being useful is like not, I think it's like, I don't know. I think one actually has to like sometimes make like sacrifices to be useful.
Yeah,
so
sure.
so that is one struggle. And then on bias, I think there's like an even maybe like kind of more foundational problem that we're facing right now with these models, which is that they just make up stuff a lot. So
yeah,
like even like you just can't, like, I guess if you use it for factual question answering, then often like if it doesn't know the answer, it will just make something up that sounds plausible. And so just like distinguishing between figuring out ways to use these models that like don't result in like you just using fake knowledge, I think is like the first harder thing. And then like bias is maybe the more subtle version of that, where things are like not even, things are not kind of literally false, but they're kind of skewed in a direction that like you don't want them to be skewed in. So I think probably right now we're not even like quite at the point yet where like bias is the like, or like the bias is so large that we're getting like literal falsehoods.
All right, awesome. Well, thank you so much for speaking to us about this.
You mentioned about it's gonna be generating visual, audio also. Is that gonna be near future? Or? I'm looking at your website and it says the likely impact of machine learning.
Yeah. It is, but it's not. I think right now these sorts of models are much better at generating text than at generating like kind of realistic vision, realistic images and videos.
Okay. Well, I was just thinking about the diamond age kind of way. Just someone.
I do think like it's, I guess I didn't say this today, but like I think the interesting thing both about generating text and about like generating vision and audio is that there are like relatively clear what people call scaling laws for both, where you can just look at like how big are the models and what is the quality of the output they're producing, and like if you make like a plot, then it's in, I guess, as a log plot, it's kind of a linear curve, and so you have like these projections where you're like, well, here's how big the models are right now, and here's how big we anticipate if progress over the next few years looks like progress over the last few years, then here's how big we anticipate the models to be in like a year or in 2 years. And so even in cases where they're not great right now, so like vision and audio are kind of maybe not even like the most clear examples of this, although are somewhat examples of this. And then there are things like logic and reasoning where the models really are not very great right now, but you can kind of see these like scaling law curves and then make projections for how good you anticipate for them to be in the future. So a lot of our work at Odd is kind of predicated on like being like, well, these models are kind of neat right now, but they're not like super great. And so, but they might be like quite good in the future. And so you want to build like infrastructures so that you can slot in the good models in the future and make them useful for like reasoning and the sorts of problems that are kind of actually benefit people.
Also, same, I'm not quite familiar, but like I wonder if it can be built upon like the users, like it has like some sort of like a profile-based learning.
Yeah, yeah, I like that direction a lot. So I think maybe I should again go back to sharing the screen. I think the most exciting vision of this for me is both like it learns from feedback that you give. So I guess we had like one example is like just these little check marks that I made, right? But then, and then the other one is like, the user actually defines like actions that they like. And I think there's like there's a more advanced version of this where basically just as you're typing and like doing your own thinking, sometimes you mark things and you're like, okay, now train an action on that, or like, remember that sometimes when I think about say how to structure my day, I like to break it down into what are things on my calendar, how important is each thing, how urgent is each thing, and then I do like some aggregation or something like that. And so ideally the user can define, can kind of demonstrate these sorts of like cognitive steps once or a few times, and then the model can learn, and then like specific to that user, just help them automate those steps in the future.
I had a question. So yeah, I'm really impressed by this algorithm. So like my question is like, since first for an algorithm like this, like the training data set must have been like really robust and would have factored in like a lot of real world conditions, right? Like to make predictions for the future. So I just wanted to know, like, what are some of the factors that you considered while making up your training data set?
So this is largely based on kind of a pre-trained language model, and like the thing that the language model is trained on is like this is basically just a ton of internet data. Like there's this very large data set called Common Crawl, which is like, I don't know, 1 trillion words or something like that, something crazy.
Oh wow.
And then the model is basically just trained to predict the next word or character like at each point in the data set, and implicitly by doing that it has kind of learned a lot of world knowledge, because to make good predictions about what words like follow other words, you need to know a lot about the world. So this is not like really specific to forecasting anyway. It's just general, domain general knowledge, and then domain general knowledge with like a very small number of kind of specific things. So I guess if you look at, we had the operationalized question earlier, it does have like some specific like examples of like kind of general questions, like what's the demand for AI talent, and then more measurable sub questions. But the specific data set is a very small, it's like something like 15 or so specific examples, and most of what it's trained on is really just domain general stuff.
Awesome, thank you.
So if I understand it, like those questions generate some sub questions that kind of make it a little bit more clear. Is that right? Like,
yeah, that's the intention, or that's like one. That is the operationalized action.
oh, cool.
But you could define other actions. Like another one I played with at some point was just a generalize action that takes a question and makes it less clear by giving a vaguer version of the question, which can also sometimes be useful.
Will it be possible to write a blog about it?
No.
No.
I mean, what do you mean? Yeah.
Well, I mean, just like get the answer, sort of like just summarize or make an abstract.
Yeah. Yeah, I think like taking a structured tree like the one I showed you and then turning it into a summary paragraph. I think that would be a reasonable other action to define.
Okay.
So I noticed a lot of these actions are hard coded, or like the user has to define them. In the future, will it kind of be like when you click on the node, it kind of infers like what actions would be relevant based on the context, and could possibly even like generate a new action if relevant?
Yeah, that's a really great question. So the infer which action is relevant definitely seems easy, and we should probably just do it now, because it's kind of a neat action to define. Like here's an example of like context and the actions that make sense, and then like that is itself an action. And then defining new actions at runtime I think there's something, I don't know which version of it makes most sense, because in some sense, then you don't even need to define the action in terms of like training examples. You just have the model suggest, here's a thing I could do, and then the model does it. And that maybe that's like a very general, maybe there's like one very general action, like, I don't know, do what I mean or something like that. And then you have examples of instructions and like the outputs. And I expect that wouldn't work well with models as they are now, but I could imagine then in a couple of years it would like do something useful.
Yeah, I think that might be necessary to fully automate the reasoning process. Have to do all those steps and more.
Yeah.
And also an additional question was, yesterday we talked briefly about the alignment problem, but I was wondering if you could go more into how you see Aught helping out with AI alignment.
Yeah, I think there's like different ways or like different problems here maybe. So one that might or might not be included under your concept of alignment is just as these AI technologies get more widely deployed, in some sense, like the world might become like more complex or less predictable, because now there are all these actors in the world who are using these AI tools who are like to reason and make plans. And so part of Aught's vision is to just use those same tools to push things more in the direction of like understandability, transparency, making it easy for people to reason about what's going on and stay in control. And that I think that applies even before like AGI or before there's like really like powerful AI around. And then I guess the other angle is, we touched on it briefly earlier, is something related to kind of transparency of reasoning, where if you could train AI systems to execute the sorts of reasoning steps that human would execute if they like could think for longer and for smarter and so on, then that is plausibly a better way to train AI systems than something like reinforcement learning based on like some feedback signal that doesn't say much about like that doesn't really communicate what processes for arriving at the output are good or not. So especially, I think, especially for things like long-term forecasting, where you don't really have good feedback and where like all you need to rely on is kind of how good is the reasoning. We don't currently have great strategies for training AI systems to help us a lot. And so by training AI systems to imitate the sort of reasoning that people do, like plausibly you could figure out how to use like these more advanced AI systems to help us do better at tasks like forecasting where we don't have good feedback signals.
For sure. And then I was also just curious about how a system like Aught might reason about things that aren't known, or I know like for long-term forecasting, obviously it's not known that well, if at all. But like, for example, could you ask like a theoretical physics question to Aught, and would it be able to make a I guess sometimes the system might need to do like experiments or something, but like how would a system like Aught play into something like that?
Okay, yeah, I feel like there are multiple kind of interesting questions in this question. So one is just about like kind of special domain knowledge. So certainly like the current type of system wouldn't do a great job at any kind of domain specific reasoning, just because that's not the sort of thing it has been trained on. It's like not, I guess there's like some theoretical physics that's part of this common crawl corpus, but it's not a lot. And so in general, whenever there's like domain knowledge that it would need that it doesn't have, it's like going to be pretty bad. And then there's maybe the more forward-looking part of your question that's about like interacting with the world, or like, you know, if there are things you can't just answer through reasoning, if you need to like run experiments to learn stuff, how does that work? And there, I think mostly I think about it as like there's a question you can ask, which is which experiment makes sense to run next, or like which action should I take in the world? And that is like a reasoning question. So because then you can just be like, well, what are the different actions I could take? What are the considerations in favor or against each of these actions? Like on the whole, which action is like best according to my desires, or so, I don't know, some process like that. So I think if one could do a great job at like kind of using AI for this sort of open-ended reasoning, then I think it would be like pretty straightforward to reduce acting in the world to a reasoning problem and make it useful for that.
That makes sense. So basically, it's like to properly answer this question, this is the context I need, and to gain this context, I need to perform these actions, and that would be an output, and then a human or someone else could do those actions and give the answer, and then it would complete its reasoning process.
Yeah, it could be a human doing it, or it could just be like literally, I don't know, the outputs go to some actuator and go to a robot, and the robot just implements it.
Yeah, for sure.
Are those questions like weighted to like the most probability on the top? Like basically, are they sorted in such a way, or okay?
Yeah, so
most relevant is on top.
Yeah, for the search questions, that's definitely the case. And then for the other ones, there's like some stochasticity, but tendentially the more relevant ones are towards the top.
How do you integrate ergo and then the factor cognition also? If you have any thought about like how you can synchronize all those research that you're doing?
Yeah.
The one you show is illicit, right?
Yeah. So I guess you're pointing at some of our other research that is more about kind of reasoning about probabilities and like kind of building probabilistic models that have like that are compositional, have other models as small pieces, and I think they could fit together nicely, although we're not actively pushing that hard to fit them together right now. In that, like probably if we went further down this tree, at some point, probably you just want to get to a place where you're like, well, either there's a number that is an answer to this question, or I can't actually get the number, but I have like some belief distribution on what the answer is. And then there's some probabilistic reasoning where I take like my distributions that I give as answers to like smaller questions, and then think about, well, given that like I think the number of these graduates is between like 1 and 10 million, and is like this log normal distribution or whatever. And given that I have like other distributions for these other things, what should I believe about this overall question? So I think there's like there's a path where this sort of more qualitative reasoning that we're looking at here and this more quantitative reasoning like converge, and like they're just two components of things you need to do when you're doing forecasting.
Okay.
So with existing models, you mentioned earlier how they're very confident in their predictions regardless of like how accurate they are. Do you think that a tool like this could be used to make like the reasoning steps of such models like more explicit in a way, so that way they could because part of the problem that people see with AI systems is that they're confident in their predictions, like or like if they're given a certain set of preferences, they're very confident that those are the right set, and they don't question them. So would your tool be able to maybe make it possible for a system to be like more humble in a way, like to say like I don't know, or yeah, basically to admit that?
I think it could be like a step in this direction. So maybe one analogy is to like mathematical proof systems, where you have a theorem prover, and the theorem prover can try to like prove that the theorem kind of is like valid or not, or it can like fail. And so maybe there's like something similar that could be going on here, where you can try to create an argument that like an answer to this question is X or not X, or you could just fail to like create a good argument. And then that's like failure to create a good argument could be this sort of like outcome where you're like, okay, I guess the system doesn't really know, because it couldn't like explain its reasoning in terms of like steps that were all individually checkable.
Yeah, that's good, because yeah, some approaches to the alignment problem, like Stuart Russell mentions inverse reinforcement learning, where kind of the models are designed to be less confident in what they think that like the problem like the problem with alignment or that people have right now is we want the machines to, or like we want the models to do what we meant, not what we like literally and like programmed. So I guess in a way, like if these reasoning models are successful, they could kind of say like, I'm not sure if this is what you meant, rather than being so confident. So
yeah, it's tough. It's tough because like failing to do what you meant could actually in some cases be worse than doing just what you like, you know, if there's a system where I know it's just literally going to do what I tell it, then in some cases that is like more predictable than if I have a system that is trying to do what I meant, which maybe is like mostly great, but sometimes could be terrible. So I think there's like making systems that do what you mean and doing that reliably is, I mean, I guess that's just the alignment problem.
right. I mean, if it can like accurately figure out what you mean, then it will also know if you like meant it to literally follow instructions. But I guess the problem is like when it's not that accurate in figuring out what you meant. So. But in that case, if it recognizes that it's not accurate, I think that's the most important thing, is like recognizing when it might be in error rather than just being so confident in itself.
Did you cover all the questions that were in the form that people submitted?
Yeah, I think I didn't ask them literally, but I think the answers that we got answered most of them.
Awesome. Well, did anyone else have any last questions here?
I am interested in having you for a podcast. Yeah.
Okay.
How can I connect in the website? Your
yeah, I'm pretty easy to find. Just search for my name. And
okay.
There are not many other people with my name.
I will then. Yeah, I send you in the chat our overview. Like, is this a non-profit?
Yeah.
We're trying to make the education and learning better, and I think this is the right fit. I feel like it's in the chat that I can send it.
Cool. Yeah, I get it.
Yep.
Yeah, that actually brings up something else. So even in like a beneficial outcome where like we make friendly AI or whatever, there's a concern about being like overshadowed. Like if AI could do everything, what's the role of people and stuff? Like how do you see like so the goal is to automate reasoning, but how do you see these kind of systems like augmenting human capabilities in reasoning as well?
Yeah, I think that's like generally a hard question. I think and I think to some extent like it's hard. It's probably like best to just make incremental progress on it and kind of at each point ask like what tools can be built that most empower people. So I think part of the hope with our tools as well, you know, we build tools where systems are kind of trained to be as helpful to the individual, like in the way that they want them to be helpful, and then it's less like there is like this single AI system that can do like whatever anyone can do. It's more like, well, you know, you have your tools that you kind of customize to yourself, and maybe in some ways it's more a thing that can become part of people's identity than like some external thing that people feel threatened by. But I don't think I have a great answer to this question. I think it's hard to have one without knowing more about what the future is going to be like.
For sure. So kind of like the Neuralink merge with AI scenario.
I have a question actually. There's a UNESCO event coming up. Are you gonna be part of that also? That is talking about the education and AI directly.
I don't know what the event. Maybe you can send it to me.
Yeah, I think that will. There's like Minister of Education of China, Croatia, and all those other people just Yeah.
Udi,
I have-
sorry to interrupt, but do you mind taking this offline too? I think it'd be easier that way to maybe communicate over email or.
Oh, I just need to find the link. That's all.
Okay, for
Okay.
sure.
Yeah, here you go. I'll just send. And you can, whoever want to check it out too. There. It's next week.
Okay, awesome. Are there any other last questions?
This isn't really relevant to like ML or anything, but where does the name come from?
You want to build systems that like do what they ought to do. And,
That's what I was thinking. I like it.
Yeah. Yeah. There's something like, the hard thing often is like figuring out what should you do and not so like, or and both figuring out what you should do and then doing it are both hard. But like often the aspect where you try to figure out what you should do is like underemphasized, and a lot of the tools that people build are more about like execution and less about like reflection on what should be done. And so that's kind of more our emphasis.
Mm-hmm. That makes a lot of sense.
Yeah. Well, I'm glad that people are working on those kind of tools. Thanks for coming, Andreas.
Yeah, this was a lot of fun.
Thank you
Thank
so
you very
much
much.
for setting up all this too. Sakit and
Yeah.
Andres, thank you.
For sure. Well, thanks everyone for coming. I'll post the recording somewhere so you all could reference it later if you'd like.
Awesome. Thanks.
Thank
Thank
you.
you.
Thanks for organizing.